Okay, well, okay, hello everyone. I am here to talk about with you on the future of XCM. First of all, let me kind of introduce myself. If you don't know me before, my name is Keith, and I am the XCM team lead for Parity Technologies. This is how you can find me on GitHub and on on an Element as well. So, there are basically two agenda items that I would like to talk to you about today when it comes to the future of XCM. The two main topics I will cover is, first of all, the RFC process, and secondly, the proposed XCM version 4 features, which we kind of expect to be, released by the end of this year. And so, first of all, the XCM RFC process. What exactly is this RFC process? So this RFC process for XCM is based on the Rust RFC and the Polkadot protocol proposals process, with a few key differences. But before I go onwards and talk about the differences, maybe I should step back a bit and kind of let you know what are the main considerations of adopting all these processes all together. One of the main considerations that we have here is that we have to realize that XCM is actually a live document, similar to HTML, for example. It's very much like Rust RFCs. If you have been contributing to Rust or Rust features before, you will know that Rust doesn't really have a standard protocol, or rather a standard defined even. And so it's also kind of like the HTTP as well. HTTP also does not have a well-defined one single document where it defines everything exhaustively. So in that world, the RFC process actually fits very well because it's kind of like a couple of design documents, kind of working in tandem with each other, with no one single document exhaustively explaining everything. The XCM format, however, is not that kind of document. It is a single document that exhaustively explains everything that has to do with the XCM format. And so you might want to ask me, hey Keith, why are we even considering using the RFC process? And the simple answer here is, this is a process that Rust programmers are familiar with, and most of the programming community are familiar with. And we do know that currently this is not the most suitable process, but having some process is better than having no process at all. I'm pretty sure we all agree with that. And so let's move on into the few key differences that we have with the Rust RFC process or the Polkadot protocol proposals process. First one here is, as I mentioned, the XCM format is a live document. The way in which you can understand live document is this. In any moment in time, you can take a snapshot, and it will describe everything down to a T. And it will be pretty much correct and complete. That's difference number one. Difference number two, changes to the XCM format needs to be made after the RFC has been accepted. So this is also an artifact of why we're adopting the RFC process. The RFC document is pretty much just one document, but then we also need to have another process there that updates the live document itself. And hence, we have this additional process here. Difference number three, code changes are then also made after changes to the XCM format document. Now, this here then kind of indicates to you that in standard terms, XCM is the XCM format document, live document, is the word here is prescriptive kind of document. What do I mean by prescriptive? It means that before we have a certain XCM feature, a proposal is created first to describe the proposed changes, rather than descriptive. Descriptive documents are kind of like HTML, where it documents only current behaviors that are common across browsers. XCM is not that. It is a prescriptive document. So to kind of picture how the process looks like, I created this nice little graph here to let you visualize exactly how it looks like. So you have the RFC document on your left-hand side. The dots here kind of indicate the completeness of each of these items here. We have the XCM standard, which is basically the live document I'm talking about, and the Rust code that, or rather the implementation of the XCM standard. Now, you can see that we have a generally really nice water flow model going from creating an RFC and then moving on to the draft. Then finally, it goes to this review process. And finally, and then it goes to what we call an FCP, a final comment period. Those of you who have participated in the Rust RFC process will be very familiar with the final comment period. It is basically a time frame where final comments on the draft proposal can be made. After that, we make a decision on whether your proposal is going to be accepted or rejected, or whether we are going to postpone it. So, 3 results, possible results. Assuming that we accept your proposal, it will go through this stage, and this is where we can start implementing changes by updating the standard and updating the Rust code to support the new feature. And then finally, it goes to the enacted stage, where everything is in place. As I mentioned before, this process, we already know ahead of time that this process is not complete, or rather, it's not as organized and ordered as we would like it. But if you have any ideas, please come to us, open an RFC. Even this process itself is an RFC by itself. This is RFC number 1. Yeah. I guess one more thing to talk about additionally is who gets to review these RFCs. Initially speaking, I would think that the XCM team that has been newly organized, by the way, this year, will be approving the PRs, just simply because it's easier at the beginning. But the vision here eventually is to have a sort of technical fellowship, not just a technical fellowship, but some sort of fellowship that encompasses all the parachains together to accept and judge on this, to basically judge on these proposals. It makes sense since they are the main users and benefactors of XCM. Okay, with that said, there are additional features that we will like to add as Parity that we would like to add to XCM version 4. Do note that because of this new process, new RFC process that we're introducing to XCM, even Parity ourselves are going to be adhering to the RFC process. So anyone in the community can take part into making XCM version 4 and version 5 and onwards. So the first feature that we would like to add into version 4 are asset holds and freezes versus reserves and locks. This is basically mirroring the changes that we had on Frame. If you have not been following changes to Frame, what this basically is we currently have a new trait that we have a new trait that abstracts currencies and fungible tokens. There are subtle differences as to how they are worked on, and whatever we suggest here is simply mirroring the changes to what happened on Frame. Is this a good change? I don't know. Should we always 100% follow what Frame does? I don't know either. We should discuss. The next proposed change that we have as Parity is asset creation. And this is simply a way of a generic way of declaring that an asset should be created. That's probably a misnomer. It's more like an asset, a generic way of declaring that an asset should be initialized, rather. So the instruction we have right now is called initialize asset. This kind of replaces the sort of ad hoc way that we have right now by using transact. If you want to use XCM to create a new asset nowadays, what you have to do is you have to make a call to the target chain using the transact instruction to basically call an extrinsic on the target chain that specifically mints an asset or creates an asset. Initialize asset is a generic way of expressing that. Now, onto something that's a little bit more interesting. The next feature I have for you is to set an agent on the recipient chain. This is basically your controller account, similar to that concept in staking. So the agent account acts on behalf of the sender for the recipient chain. This could be useful in cases where you want an account to be controlled by you by the sender locally, and you want to specify it when you send the XCM. So the two new instructions that allows you to accomplish this fact is set agent and reset agent. This account that you create will be tied to the sender or sender origin, and it would exist on the receiving parachain. And this agent will then simply act on behalf of the sender. This will be very, very useful when it comes to exchanging assets, because when you try to exchange assets using XCM, you absolutely must need an account to do so. Transacting, but rather returning the exchange asset to the holding register is something that you cannot do. You must always supply an account. And so in the case where you need a temporary local on-chain account, this is where it comes into handy. Next one, voting, governance, delegating votes as well. Currently, there is no way of using XCM to generically to vote or delegate on another chain. And this is simply basically a set of governance features that we think are pretty primitive and common across all uses of governance. So you have vote, unvote, delegate, and undelegate. As I'm explaining to you about this, I do get the feeling that delegate and undelegate might not be very used in each and every use case. In which case, you can choose not to implement delegate and delegate on your chain, and that'll be fine as well. Next feature, origin mutation. Now, this here is a feature that is going to be very interesting for those of you who have been working with XCM, specifically with reserve asset transfers and teleportation. When you work with these two instructions closely, you would know that there's always a clear origin instruction that gets inserted by the XCM executor in order to prevent further privilege escalation attacks. But it is needlessly too restrictive. So one of the ways in which we want to improve upon this is to say, how about we step back a bit? How about we allow the possibility of temporarily modifying my origin, the origin register, clearing it, and then running the specified XCMs that we want in a sort of sandbox. Once I'm finished with this sandbox, I can throw that away and then return to the original origin that I have. Now, this is going to be very, very useful for one particular use case that I've been received that I know that a lot of chains would like to have, and that is reserve transferring assets to another chain and then immediately calling transact. Currently, that sort of feature is a bit iffy in XCM version 3, but with XCM version 4, hopefully that you guys agree that we are going to implement this feature, it will be much easier. So, the most important thing about all of this process here is all of you. We have created this XCM RFC process because we know that decentralization is important. And most importantly, being resilient is important to support all of your use cases. We have also specifically designed XCM to be extensible and configurable. Most of the changes that we have here are simply thoughts that we have for Parity, that we have at Parity. You should not treat them as the ultimate truth. We may have design considerations that have been built into the XCM protocol, but they need to be reviewed from time to time. It's not always necessarily going to be held true through time. And so this process here helps us move together towards the decentralized future that we all hope to achieve. Thank you very much.